the second part of 7.2A, continued. And this would be example 4 if we're continuing on from yesterday, right? So I have f of x equals 10x to the fourth minus 11x to the third minus 42x squared plus 7x plus 12. Okay? So, can I factor? No. Nope. Can I use quadratic formula? No. Not currently because we don't have a second degree. So, what should I do? Come up with my list of possible rational roots, right? So I need to start off with the factors of the constant. What is my constant? 12. So what are my factors? 1, 2, 3, 4, 6, 12. Yeah? Factors of my leading coefficient. My leading coefficient is 10, so I have 1, 2, 5, 10. I think my list of possibilities is going to be kind of long, isn't it? All right, so I start off by putting all of those constant factors over 1. So 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. Yeah? That's 1, 2, 3, 4, 6, 12. Yeah? Now I put them all over 2. So 1 over 2 gets added to my list. What about 2 over 2? That's 1 already on my list. 3 over 2?
Yeah.
I need to add that one. 4 over 2 is 2. 6 over 2 is 3. 12 over 2 is 6. Now what do? Put them all over 5. I don't think anything over 5 is going to reduce from this list, is it? So 1 over 5, 2 over 5, 3 over 5, 4 over 5, 6 over 5, 12 over 5. Those are ugly fractions. And now I put them all over 10. 1 over 10. What about 2 over 10? That's 1/5. 3 over 10. Got to add that one. 4 over 10 is 2/5. 6 over 10 is 3/5. And 12 over 10 is 6/5. So everything else is there. That is a ridiculously long list, isn't it? I would not give you a problem like that and not give you a graph to look at to help you start guessing. So let's see. If I pulled out my graph, working on charging it here, hang on. Let me type in this graph. So 10x to the fourth minus 11x to the third minus 42x squared plus 7x plus 12. And I look at the graph of that. Let's see what we get. Okay. Whew. How many intercepts do I see there?
4.
I feel like I can see 4 fairly reasonably. I'm going to zoom in a little bit. Zoom 4. So hopefully I can see a little bit more clearly. Do any of them cross at nice places? No. What a pain in the tushy. Yeah? Do any of them look like they cross at nice places? Like I could kind of try and highlight there. Negative 0.5, that could be one. Should we try it? Negative 1/2?
Yeah.
That's one of our numbers. Let's try it. Negative 1/2 as my box number. Do I have any placeholders that I need?
No.
4, 3, 2, 1, 0. No. So let's go ahead and do this one. 10 times negative 1/2, negative 5. Negative 11 and negative 5 is negative 16. Negative 16 times negative 1/2 would be positive 8. What's negative 42 and positive 8? Negative 34. Negative 34 times negative 1/2 would be 17. 17 and 7 are 24. 24 times negative 1/2 is negative 12. Hallelujah, it worked. I was a little worried there. So, how many answers am I looking for total? 4. And negative 1/2 is one of those 4 answers. I'm going to make my answer box over here. Notice I made my answer box really big because I have no idea what the other zeros are going to look like. They could be quadratic formula answers. So I have 10x to the what?
Third.
I was at the 4th, now I'm to the 3rd, minus, 16x squared minus 34x plus 24. Do you notice anything I could do here? I can divide by 2. Let's make those numbers smaller. Go ahead. As soon as you can, do it. So 10 over 2 would be 5x to the 3rd, minus 16 over 2 would be 8x squared, minus 17x plus 12 equals 0. Okay. So now I have to find another number. Now if I think about it, my list of possibilities at this point, I can shorten a little bit because one of these 2 numbers changed from the original. Which one changed? 12 is still the same, but I don't have a 10 anymore. I have a 5. So I'm most likely not going to try any of those ones with the 10 on the bottom because that's no longer my leading coefficient. Like if I recreated my list of possibilities here, those 2 numbers wouldn't be on that list. Does that make sense? Okay. Can I use grouping at this point? No, because I wouldn't get those matching parentheses, would I? So let's see what else we can do. If I can arrow over here, negative 1.5 looks like it could be reasonable. Should we try it? That would be right here, negative 3/2, right? Negative 3/2. And I have 5, negative 8, negative 17, and 12. Bring down the 5. Uh-oh, is this going to be ugly? 5 times negative 3 over 2 is negative 7.5. Why did I get a decimal? Any guesses why I might have gotten a decimal? Because I don't really want to continue if I'm going to continue getting decimals over and over again. Any guesses as to why I got a decimal? I'll give you a hint. The denominator here is a 2. What did I divide by? I wonder if I go back and use these coefficients, if I'll be able to keep away from the decimals. Should we try that? Let's go back and pretend we didn't divide by 2. So negative 3 over 2, and using that 10, negative 16, negative 34, and 24. Just because I feel like the further I get with those decimals, the uglier it's going to get, right? Because 10, I can multiply by negative 3/2. 10 times negative 3/2 is negative 15. Negative 15 and negative 16, negative 31, yeah? Is that going to multiply by negative 3/2 nicely? No, I'm not getting anywhere nice, am I? What does that tell me? That tells me that perhaps this isn't crossing exactly at 1.5. That's not a good 0. So maybe let's just go back and try a different number. What about over here? 0.6? Do we know what 0.6 is as a fraction? Isn't that 6/10? Right? 0.6 is a 6 in the 10th place. So that would be 6/10. Let me say that. 0.6, that's a 6 in the 10th place. That reduces to 3/5. Is that on my list?
Yes.
It is. How about we try 3/5? Now, 3/5 should work with my the one right here where I had divided by 2. So let's try that one again. I'm kind of glad this one's messy so that you can see what I do to work through a messy one. So let's see. 5, I'm bringing down. What is 5 times 3/5? Again, use your calculator with that fraction button. Don't try and do it all by hand. 5 times 3, fraction button 5. It's 3. Negative 8 and 3 is? So what's negative 5 times 3/5? Negative 3. Negative 17 and negative 3. And negative 20 times 3/5 times 3/5 is negative 12. Finally, we got one that works out. So 1/2 is one answer. 3/5 is another answer. And thankfully, I'm now down to what? X to the second. So 5x to the second minus 5x to the first minus 20 equals 0. Can I divide before I go to quadratic formula just so that I'm dealing with smaller numbers? Yeah. So I get x squared minus x minus 4 equals 0. Am I sure I can't snowflake? Negative 4 and negative 1. No, I can't snowflake, can I? All right, so why don't you take a minute, use your quadratic formula, and finish off that problem. So let's see, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 4 all over 2a. So negative 1 becomes positive 1. Over here, let me do it on this calculator. Negative 1 squared minus 4 times 1 times negative 4 is 17. All over 2 times 1 is 2. And breaking that up, I get 1 over 2 plus or minus radical 17 over 2, right? So 1 over 2 plus or minus radical 17 over 2. Now I'm just curious because remember when we were looking at the graph, this point looked like it was negative 1.5, didn't it? It looked like it was pretty close to negative 1.5. I'm curious as to if one of these two, if the decimal's close to 1/2 or negative 1.5. So I'm going to do 1/2. You don't have to do this on the problems. I'm just curious. Plus radical 17 divided by 2. Put some more parentheses in there. So this means that one of my roots should be at 2.56-ish. 2.56, somewhere in here. Do you notice it's between those two values as I'm arrowing around? And if I go back and I do the minus one, I'm guessing that's going to be the one close to negative 1.5, negative 1.56. So it wasn't exact, which is why it didn't work out here, but it was pretty darn close. Okay? All right, so that was the last one. That one was super ugly. Your homework is actually 7.2C. I called it C because it's a worksheet that I kind of added to it. It's only 8 problems, but they are ones that kind of combine all of our methods. Some of them you may be able to factor and get your zeros that way. Some of them you may need to factor out a greatest common factor before you can factor it. Some of them may be in this format, plus 16 or something like that, where you have the middle one cut in half. You remember that pattern? You can still snowflake that. So be looking for all of those things because they're all involved in those 8 problems. Okay? All right, happy studying.